little bit 2 days ago. I'll just remind you, it's very similar to what you did with lines. General form is called ax squared plus bx plus c. Standard form, also called vertex form, is what we looked at up until this point, which is y equals a x minus h squared plus k. Remember, h and k, p and q, we don't care. It's the exact same thing, just different books use different things. And standard form is what we want, because that's how we get the vertex and the axis of symmetry and the direction and all those great things. So all we're going to do today is show you how to flip one into the other. So we'll start with the very base parabola, x squared plus 6x plus 8. And imagine for a second this didn't say change to standard form. Imagine this said solve. And I said to you, you have to use completing the square method to solve it. What would you do as the first step? Take the middle, divide by 2, and square. So I'm going to keep the first term, I'm going to keep the last term, and I'm just going to push that 8 off to the side. And I'm going to leave that space. And we know we take what's called the b value, divide by 2, and square it. And so 6 divided by 2 squared. So we end up adding 9. Now this step is going to be a little bit different than what we did last unit, and I'll tell you why after. Last unit we added 9 to one side and then we added 9 to the other side to balance it. The problem is I don't want anything over here with the y. I want the y all by itself. So instead of adding and adding, on the same side I'm going to add and subtract to balance it out. It's the same thing as adding to this side and just bringing it over. I'm just going to do that in one step. So if I add 9 to the right, I'm going to minus 9 to balance it off. Sorry? How so? So if I simplified, yes, it would get me right back, and that's the point, is I'm not changing the equation. I'm just adding a number in order to be able to factor it in a second. So now what I'm going to do is group the first 3 and factor them. And again, this is just what we did last method, or last unit for method 3. I know I'm going to have a binomial squared. Remember, this is a perfect square trinomial, so it factors into x plus 3, and that comes from the middle divided by 2. And then all I'm going to do is simplify these guys. So the last 2 numbers I'm just going to combine together, plus 8 minus 9 minus 1. 9. How did we get x plus 3 squared? Who can tell her? It's just product sum. What are the 2 numbers that multiply to give us 9, add to give us 6? So it has to be 3 and 3 because it's a perfect square trinomial. You don't need to know any of this, but this is kind of cool. Remember algae tiles from grade 9? You probably hated them, let's be honest. Okay. What algae tile is that? It's an x. And what's that one? And so this, if I colored them, I'm really just too lazy as x plus 3. Right? Okay, and what's that? Like, let's pretend it was actually nicely drawn, not like that. And then if I put 3 little ones, this side is also x plus 3. And again, let's just imagine I colored them and they looked fine. Well, what we had in the question is we had an x squared, and we had 6x. When we complete the square, when we take that middle and we divide by 2 and we square it, what we're really finding is how many little cubes need to fit in that space. That's mathematically what we're doing is when we divide by 2 and square. So 6 divided by 2 we said was 3, and 3 squared is 9. Well, how many little guys are going to fit here? 9 of them. Okay, you with me still? What shape does this make?
A square.
So you're called completing the square because that's what you're doing. You're physically filling in the rest of the square. That's why it's called that. You still with me up to this point?
Yes.
We stop now. We don't need to go ahead and solve it. That's what we did last unit. But this question isn't going to say solve. This might say find the vertex or find the axis of symmetry. Well, what's the vertex of this? Negative 3, negative 1. What's the axis of symmetry? X equals negative 3. Does it go up or does it go down? So what's the direction? Up, because there's no negative in front. Because it goes up, what's the max or min? It's a min at y equals. You're doing range, back off. Equal to negative 1. Do you see how we don't like, or where's the question, this form because we can't tell anything? There's no way to quickly look at this and know the vertex would be negative 3, negative 1. That's why we love this form. That's it. That's completing the square. It's just the first step of what we did last unit. Okay, so let's look at example number 1 down here. For the parabola y equals x squared minus 8x minus 7, is its vertex 8, negative 7? Yeah, so probably not, because when a question's asking you something that obvious, it's probably not. What's the only way to find the vertex of this parabola? Complete the square. That's what we're doing all today. Completing the square. We keep the first two terms, and I'm just going to push that last term off to the side. I don't need him until I'm collecting those constants at the end. Some people like to put blanks to know that they need to fill in two numbers. If that works for you, great. If that doesn't, don't write it down. The blank is always going to come from the middle divided by 2 squared, so negative 8 divided by 2, negative 4, and negative 4 squared. If I add 16 on the same side, what do I need to do at the end of that side? Subtract 16. Again, if you like last unit when we added to the other side, you can do that. You're just going to turn around and then bring it over in the next step. The reason last unit we did it on both sides is because we didn't care if y was by itself. We didn't care what was on the other side. Now I want that y by itself. Okay, I like to box the first 3 to factor them, and I like to circle the last 2 to combine them. That's just the way my brain works. If you're not a circler, don't circle. It's always going to factor into a binomial squared, and so you're looking for the two numbers that multiply to give us 16, add or subtract to give us negative 8. The pattern is always going to be middle divided by 2. So what's the middle divided by 2? Negative 4. Those are the two numbers, negative 4 and negative 4, that are going to add to give us negative 6, multiply to give us positive 16. These one we're just combining, just regular adding up of numbers. If I have negative 7, negative 16, I have negative 23. Is the vertex 8, negative 7? No way, it's not even close to that. What is the vertex? 4, negative 23. Again, could you have looked at this original and even imagined it was 423? It's not like a line that you could just quickly do it. You have to really go through the steps to figure it out. State the axis of symmetry of y equals x squared plus 12x. Okie dokie. What do we need in order to get the axis of symmetry? We need the vertex. How do we get the vertex? Well, it has to be in vertex form. So these are all going to be the same kind of question. They're all going to be completing the square. Okay, middle divided by 2 squared. Whoa, now, I only have 2 terms, so what the heck is this middle? Well, there is a third number. We just don't see it. What is it? So if your brain likes to put that in to still recognize there's 3 terms, then write it in. If your brain doesn't need it, then don't. But there really is a third term of plus 0. Middle divided by 2 squared. 12 divided by 2 squared. And if I add 36, I need to come to the end and subtract 36. Why do we need to do that? To balance the equation, because as Ethan pointed out earlier, doesn't that take it right to the beginning? Yes, that's the point, is we're not changing it. We're just kind of playing with what it looks like. Group the first 3 and factor. It's always going to be a binomial squared. It's always going to be x plus or minus something, and it comes from the middle divided by 2. Middle divided by 2 would be plus 6.
Wait, what? Oh, the 0 doesn't go in the... Oh,
No, the 0 is part of this n, so it's always the last 2 we combine together. And in this case, it's just going to be minus 36. Now, just make sure you're reading the questions carefully and you're answering what they asked for, because sometimes they'll ask for the vertex, sometimes the max min, sometimes the range. What does this one want? The axis of symmetry. So x equals negative 6. Why is it negative? Because this is a horizontal displacement to the left. And so because it went to the left, it's going to go to minus 6. How are we feeling so far? Number 3. Keep the first two terms, leave a space, push the last number off to the side. If the blanks help you to remember that there's two numbers that we're going to have to add and subtract, do blanks. If blanks don't work for you, don't do blanks. Middle divided by 2 squared. Uh-oh. 1 divided by 2. A half squared. A quarter. Okay, so fractions are not going to get us. We can square fractions. Well, if I add a quarter, what's going to happen at the end of this expression? I'm going to subtract a quarter. Group the first 3 in factor. Again, that's not going to frighten us, that 1/4 at the end.
That's quarters multiplying the half and half.
Correct.
Sure. Okay.
Correct.
Just want to make sure I didn't go lose myself.
How do we go from the trinomial down to the binomial? Middle term divided by 2, so 1 divided by 2, a half. Combine the constants. Okay, how do I add or subtract fractions? Common denominator. What's under the 5 that we don't see, but we know it's there? Okay, so 1 and 4, what's going to be the common denominator? 4. Okay, so something over 4 minus 1 over 4. Okay, 20, I heard somebody say. Everybody okay there where the 20 came from? Okay. Minus 20 over 4 minus 1 over 4. And just make sure we're answering the question. What did this particular question ask us for? The vertex, negative a half, negative 21 over 4. That's the hardest we're going to ask without a calculator. If it was some crazy freaky fraction number, we're going to let you use a calculator. But halves and quarters and things like that you should be able to do without. How are we feeling? Because I'm about to mix things up.
Okay.
You're like, great, not so great. This one here? So to factor from the trinomial down to the binomial, it's always middle divide by 2.
Oh.
So a half is the two numbers, a half times a half, that gives us a quarter, and a half plus a half equals 1. So it comes from the product and the sum. It always just comes from an x squared down to an x. So they all started with an x? Like example number 4? Why, that was a perfect segue. Coefficient in front of the x squared. What did we do with this last unit? So last unit we divided by it. The problem is I want the y by itself. And if I divide by 3 on the right, what do I have to do on the left? Divide by 3, and I don't want that. That y has to be by itself. So whenever you're dealing with a coefficient that's bigger than 1, this is what you're going to do. What I'm going to do is factor the 3 out of the first 2 terms. I'm still going to push that 16 off to the side. I'll deal with him later. So it's only the first 2 terms I care about because that's going to get my factoring in a second. So if I divide 3x squared divide by 3, it's going to leave me with x squared. And if I divide 12x by 3, it's going to leave me with 4x. And I'm still leaving that space to add the number. If you are a wordy person, step number 1, factor the a value out of the first 2 terms. Factor the a value out of the first 2 terms. Now the next step, we're just going to pretend everything was like it was before, not changing anything up yet. Middle divide by 2 squared, so 4 divided by 2. 2, and 2 squared is 4. And if I add 4, what do I need to do at the end? Subtract 4. Here's the second piece that's different. If I were to distribute this 3 through the brackets, I would get 3x squared, and I would get 12x, and that's what we want up here. But did I really add 4? So if I were to distribute this 3, I'm going to have a 3 times 4, which is 12. So to balance it out, when there's a coefficient other than 1, we also have to multiply the number at the end by that coefficient. Okay, I'm going to repeat that. I added 4 and I subtracted 4, except I really didn't add 4. If I were to distribute this 3, I would end up with a 3 times 4, which is 12. So to balance it out, I'm going to multiply the last number by the a value. If you're a wordy person, step 2, after completing the square, multiply the very last number by a. Multiply the very last number by a.
Wait, it's after we multiply thing at the end by the 3?
Yes.
Okay.
Those are the only two steps that are different. We have to factor that a value out because we need an x squared to complete the square. And when we're subtracting off that magical number, we just have to multiply by the a. Everything else is going to be the same. So Julie, to answer your question from last, you said, what if it isn't x squared? It will always be x squared. Okay, so carrying forward, I'm still going to factor these guys, and I'm still going to combine these guys. I'm just leaving that 3 in the front, just hang it out there. If I factor the perfect square trinomial, what binomial do I get? And then to simplify, I just need to do this multiplication first. So a 4 times 3 is 12, and then I've got 16 minus 12 plus 4. In terms of this parabola, what is this 3 that I factored out? What does it affect? The width, and what does it do to the width? Makes it skinnier. That's what its job there is, just to make the parabola skinnier. Sometimes I wish I could just put a number in front of myself and make myself skinnier. It'd be kind of handy. Answer the question. What did this one ask for? Complete the square. Have we done that? Yes. So that is what the question is asking for when it says complete the square. Just change it into vertex form. Number 5. The minute we see a number in front of the x squared, that tells us we have to factor because that's our width value and it's got to be out front in front of the brackets. So step 1, I'm going to take it out of the first 2 terms. I'm just pushing that 3 along off to the side. I'll worry about him later. Now, visual people, here's a trick that's going to help you with a question like this. Write the factoring as a division because you're going to see in a second what's going to happen. So negative 2x squared, and if we factor out negative 2, what are we left with? Not a trick question. X squared. The problem with this one is here. Negative 12x divided by negative 2 plus 6x. And if you don't catch that sign change right there, your vertex is going to be on the completely wrong side of your graph. So for visual people, sometimes when you write it, your brain sees the divide, the negative divide by negative. Okay? So it's really important when your a is negative that there's going to always be a sign change here. Again, if you miss it, your parabola is going to be on the completely wrong side of the x-axis. Okay, complete the square as normal. So middle divide by 2 squared, 6 divide by 2, 3 squared. Then to balance it off, I have to subtract 9, except I have to multiply by negative 2. And again, that's just to balance off the negative 2 that's in front here. The negative 2 just hangs out in front, stays there, doesn't go anywhere. We have to factor it down into a binomial squared. X plus 3. And then we just combine the constants. So first I'm going to do that multiplication, negative 9 times negative 2, positive 18, plus 3 plus 18, plus 21. What does the question ask us for? Range. What do we need before we can do the range? The vertex or the max-min, either way. In order to get the vertex or the max-min, we need to know the direction. Okay, so direction is, I like to write it because I'm visual and it helps me get the range. You don't have to write it down. I know the range starts with y and I know it's going to end with 21. We just have to figure out the sign now. Because I'm visual, I like the picture because it helps me see we need the values that are lower than 21, which are less than. Okay, so the picture there, the direction's optional. It's just how I get the range in my head. How are we feeling with that coefficient stuff, factoring it out? Okay, let's do another one. How about you do a step, then I'll do the step, then you do the step, then I do step.
How did we get that the parabola has a maximum?
Because it goes down, and we know it goes down because of the -2 in front. The negative tells the direction.
I'm guessing you mentioned that yesterday, but I get around to like 3.
Okay, so here's step number 1 is factoring that -3 out. Again, if you're visual, writing it sometimes helps to see when there's a sign change, but you don't have to. This is going to be plus 4x, and then I've got my plus 7 just thrown in the back. Did everyone catch that that changed to a plus 4? Okay, complete the square, so fill in the space. Again, sometimes it helps to put blanks to remind yourself that there's 2 numbers we're going to be putting in. Number in the first blank is going to be plus 4. Number in the back is going to be -4 times -3. If you can see that you're going to multiply and right away you want to put plus 12, that's fine. So if you can see that you're going to multiply a -4 times a -3, great. If you didn't see it, no problem. Okay, finish it off. Inside the brackets, we're going to end up with an x plus 2. And outside, we're going to have plus 19. Answer the question. So what is the question looking for? Answer it. Question wants a vertex. The vertex is? Who had that? High fives to you guys. Just a notation thing, certain textbooks will put this in front. Would you like to guess what the V would mean? Vertex. So sometimes you'll see that. It just means it's a vertex as opposed to just a coordinate point. So again, you don't have to put it, but if you see it.
Wait, how did we get to -2? Wouldn't it be -3?
Number in the brackets, change the sign. Remember, the 3 just changes the width. Last one, on your own, with a friend, whatever you feel like. Give you a couple minutes, then we'll talk. Questions up till this point? Did you make this positive? Okay. At this point, this would be a calculator question, but if you feel brave, we can do it without calc. How do you feel? Ethan's like, no, we're done.
I tried doing it.
Let's do it without, just for fun.
I tried doing it.
Okay, just for fun.
But then I realized.
What's 5 divided by 2? 5 divided by 2. And if we square that? But let's keep it as fraction for now. So 5 squared. It's like you've forgotten everything now that you've touched your calculator.
I didn't do it.
5 squared, 25. And 2 squared, 4. Okay. We're just doing it for fun. Come on, fractions are fun. Minus 25 on 4, except we have to multiply by -4. Okay, going down to our binomial squared, we're going to have x plus 5 over 2. What are we going to do with this mess over here? Well, how do we multiply fractions? Top times top, bottom times bottom. What are the 4's going to end up doing? Canceling. So a negative times a negative gives us positive 25. What did the question ask? Complete the square. Are we done? Did we answer that? There we go. And again, if you had 2.5 from your calc, that's fine. How'd it go? Good. This is the single